Hello grade 10s, welcome to the lesson on Bohr diagrams. So this lesson is going to be a couple different parts. We're going to start by talking about what we are learning. We are learning about the periodic table forming stable compounds. What you are doing is learning how to do those in diagrams. We're going to start with Bohr diagrams and move our way through. So let's first look at the patterns we're going to see as we draw these diagrams. First thing you need to understand is when drawing a diagram, we're looking at the electrons. So electrons are how elements interact, and that's something we're going to focus on as we talk about ionic and molecular. Now, an atom has these things called valence electrons. Valence electrons are what we would say are on the outer shell of the atom. Now, if we take a quick look at this picture here, you can see these two circles. These are energy levels. This is its outer shell, and this is its valence electron, the one that's on the outside. Now the patterns we're going to see are that elements in each group have similar properties. So therefore they also have the same number of valence electrons. What does that mean? Well, it means when we draw them, we have a good idea of how to figure out where these electrons go. So if we think back to our periodic table, you have groups and periods. If you look at a group on a periodic table, it will tell you the electrons that will be found in that outermost shell based off of its group number, and it'll tell you how many shells you need based off of the period number for a Bohr diagram. So look at lithium, for example. On the periodic table, lithium is in group 1, period 2. So what that means is that in lithium, it's going to have 2 energy levels because it's in period 2, so there's 2 circles. And since it's in group 1, it's going to have 1 electron on the outside. We are going to talk about how we do that and draw this here in Bohr diagrams. So Bohr is one of the people that we learned about in our atomic theories. Bohr figured out that electrons don't just float around like the plum pudding model in a mass of anything. He figured out they belong on energy levels. So an energy level are these little shells that we draw. Every Bohr diagram will have a nucleus in the center to represent the protons and the neutrons, and then we're going to add our electrons on from there. So this very first shell is all about the inner shell. This is called the inner shell, and it is only allowed to hold 2 electrons. It doesn't have a lot of space. Every shell we add after that can have a maximum of 8 electrons on it. Now, when we get to our very last shell, this outer shell here, we call this our valence shell, and any electron on it we call valence electrons. So let's look at how we are going to draw these. We're going to start with our first example on nitrogen. So we're going to start by adding in our notes a picture of the nitrogen nucleus. Now, when I look at my periodic table, nitrogen has an element symbol of N and has 7 protons. I figured out my neutrons by taking 14 minus 7, and I got 7. Now, we're not using neutrons for this, but I added into my nucleus because that's what's found in the nucleus. What I'm going to focus on are my electrons. How do I know how many electrons I have? Well, by looking at how many protons I have. I have 7. If I go to my periodic table, I will also see that my periodic table shows nitrogen in period 2. So right away, I know I need to draw 2 shells or 2 energy levels for nitrogen. Remembering, periods are the ones that run all the way across the periodic table. I'm going to go back to my periodic table and I'm going to look and see that nitrogen is in group 15. I'm going to ignore the 1 in front of the 15 and look at the 5. That 5 tells me I need to have 5 valence electrons on the outside of this picture. So how do I do this? Well, I'm going to start by placing 2 electrons on the inner shell. As a reminder, 2 electrons are all you are allowed to have on this inner shell. Now I can add up to a maximum of 8 here, and it has to be in a specific pattern. So I'm going to start by putting 1 here, and I'm going to move clockwise around my valence shell. So 1, 2, 3, 4, just in that pattern. Now, right now, I only have 6 electrons. 1, 2, 3, 4, 5, 6, but I should have 7. So the 7th one is going to make a pair right there. And you would do that all the way around if we needed to add more electrons. So this is a Bohr diagram for nitrogen. We are going to try a Bohr diagram for magnesium. So again, make your nucleus. Look at how many protons you have. 12. So I need 12 electrons. If I go to my periodic table, magnesium is found in period 2, period 3, group 2. So because it's in period 3, I'm going to have 3 shells. And since it is in group 2, this outer shell is going to only have 2 electrons on it. So I'm going to start on my inner shell and add my first 2 electrons. I'm then going to move to my next shell, and I'm going to start placing them clockwise around that shell. So again, right now I have 6. I'm going to add a 7th, 8th, 9th, and 10th right there. Now what you have to remember is these shells are only allowed 8, so I have my maximum number. So now I need to move on to the next shell. So this is now electron number 11, and this now is electron number 12. There they are. Let's take one look at fluorine quickly. Again, 9 protons. It is found in group 17, period 2. So since it's in period 2, I'm going to have 2 shells. Since it's in group 17, I'm going to ignore the 1, and I'm going to say there needs to be 7 valence electrons on this valence shell. So I start by putting 2, and then I'm going to work my way around adding other ones. 1, 2, 3, 4. Now pairing them up. 5, 6, 7. So here's my 7 electrons on the outside, 2 here for a total of 9, and there's my fluorine. So hopefully you were able to follow along, and tomorrow we'll repick this up and discuss it a little bit about Bohr diagrams. Thanks, and if you have any questions, please let me know.